In this lesson, we're going to be talking about calculator functions for the binomial distribution. There's two of them, the Binome Pdf and the Binome CDF. So let's first start with the Binome Pdf function. We need to be able to identify n, the number of trials, p, the probability of success, and x, the number of trials, in order to find the probability using this calculator function, which this calculator function stands for the binomial probability distribution function. It is used when we want exactly one value for x. Okay, so here's an example of when we would use it. We want to find the probability of getting exactly 3 heads when flipping a coin 5 times. That tells me that n, the number of flips, is 5. The probability of success, which I'm calling heads, my success, is 1/2. And the number of trials that we want, the number of successes that we want rather, is 3. We want 3 heads. So since x is just a single data value, we would use the Binome Pdf function. So Binome Pdf of n, which is 5, p, which is 1/2 or 0.5. You can enter those as fractions or decimals. And then x. Okay, let's go ahead to the calculator. So in the calculator, we press second vars. See how it says distribution in blue right above vars? That's the keyword that we want. We want a distribution. And I'm actually going to use the up arrow because it is towards the bottom of the list. We're looking for the Binome Pdf function. Whoops, I just went past it, which is letter A in my calculator. Now, when I hit enter, a little menu pops up for me. If you don't have that menu, then you want to type it in exactly as I have it written on the screen. Binome Pdf, in parentheses, 5, comma, which is right above 7, 1/2, comma, 3. Since I have this little menu, it's asking me, what are the number of trials? 5. What's the probability of success? 1/2 or 0.5. And what's the number of successes? 3. When I hit enter, it puts it on the screen exactly how, if you don't get that menu, how you'd have to type it in. Okay, let's hit enter again, and there is the probability, 0.3125. So that's the probability of tossing exactly 3 heads when we toss a coin 5 times. Okay, the other calculator function is called Binome CDF, which that C stands for cumulative distribution function. So it's still a binomial situation, but instead of just wanting a single x, we want multiple x's. And specifically, we want x's starting at 0 and going up to a number. We're still going to have to identify the number of trials and the probability of success, as well as what x values, what number of successes we want, ensuring that they start at 0 and going up to a particular value. So some key words that we might see for this type is at most, okay? Because at most means that we could have, in this case, 3 heads or less. So we could have 0 heads, 1 heads, 2 heads, or 3 heads. So I want multiple x values that start at 0 and go up to a particular number, in this case, 3. Okay, let's go ahead and pick out n. We're tossing the coin 7 times, and the probability of getting a success, which in this case I'm calling heads, is 1/2. So since we want those multiple x values that start at 0 and go up to a number, this would be the perfect scenario for a Binome CDF. You have to tell the calculator n, then p, then the x value is the largest one that you want. So in this case, 3. The calculator is going to automatically find the probability of 0 and add it on to the probability of 1, plus the probability of 2, plus the probability of 3. So it's going to add all of those probabilities together for me so I don't have to do it 4 different times and then add those probabilities manually. Okay, so the calculator function can really save us some time. All right, we go to the same spot. So second vars for distribution. And again, I'm going to hit the up arrow key, but make sure this time we're selecting the Binome CDF function for that cumulative distribution function. Again, I'm getting that menu, but if you don't, you want to type it in exactly as I have it written on the screen. And I always tend to put my probabilities in as decimals, but again, you could put it in as a fraction. So there it is on my screen. That's how you would type it in if you're not getting that menu. And that probability is 0.5. Okay, some more examples of that. A card is drawn from a deck and replaced. That's important because remember, if we're not replacing the card, they would not be independent, and therefore we could not use binomial on it. So they have to be independent events, which if we're replacing cards, they would be independent. Out of 10 draws, what is the probability that a person will get exactly 2 aces? Okay, so picking out n, we're drawing 10 times. The probability of success, our success in this case is drawing an ace. So the probability of drawing an ace is 4 out of 52, or reduced form 1/13. And then what x values do we want? It says exactly 2 aces. So we just have a single x value. So this is a Binome Pdf. N is 10. Probability is 1/13. And the x value is 2. This time I am going to put in that probability as a fraction. Oops. So n is again 10. Probability is 1/13. So we see that we can enter those as fractions. And 2 is the number of successes. Oh, I accidentally selected the wrong distribution. So let me go back. There we go. I might have got click happy with that last time. Okay, let me clear that out. Oh, no, my calculator is... Okay, let me just clear all this out of here and start over. Okay, there we go. Binome Pdf. Okay, yay, it worked. All right, we've got 10. We have 1/13 as the probability. And we have 2 as our successes. Okay, we get a probability of 0.1404 if I round that to 4 decimal places. Right, this next example says 26% of couples who plan to marry this year are planning destination weddings. In a random sample of 12 couples who plan to marry, find the probability that fewer than 8 couples will have a destination wedding. Okay, so N, we're picking 12 couples all together. The probability that they'll have a destination wedding is 26%. I'm going to write that as 0.26. And X, we have to be careful here, fewer than 8. So fewer than 8 would mean 0, 1, 2, all the way up to 7. I would not want to include 8, fewer than 8, right? Okay, so this is the perfect scenario for a Binome CDF because we're starting at an X value of 0 and going up to 7. So N is 12, probability of success 0.26, and the highest value that we want to include is 7. All right, let's make sure that I select the correct distribution here. Binome CDF, perfect. N is 12, probability is 0.26, and the X value, the highest one that we want, is 7. Again, the calculator is going to add all of those probabilities together for me, so it's saving me a lot of time there. That probability comes out to 0.9964. Again, rounded to 4 decimal places. Okay, why don't you guys try this one? Pause the video here, see if you can find those answers, and then unpause the video when you're ready to return. Okay, hopefully you've had enough time. The first one, we do a Binome Pdf of 20.9518. With number 2, it was a Binome CDF of 20.9517. No more than 17. We want the x values from 0 all the way up to 17. And this last one was tricky because it asks us what's the probability that more than 15. So we actually want the x values from 16 and up. That is not a straightforward PDF, and it's not a straightforward CDF because remember, CDF will always start at 0 and go up to a number. So if we think about the outcomes that we do not want to include, if we want 16 through 20, we don't want 0 to 15. So I did a Binome CDF of that, and then I'm using complement rule to find the probability of the outcomes that I do want. So I took 1 minus a Binome CDF of 20.95 comma 15, and I got 0.9974. Okay, there is one more type of question that I want to look at today, and that's the idea of between. So the probability of going to the movies this weekend is 42%. If 25 people are randomly selected, what is the probability that between 5 and 12 people go to the movies inclusively, which means that I want to include the 5 and include the 12. Okay, so if I want the x values from 5 through 12, this is not a straightforward PDF, and it's not a straightforward CDF. So I'm going to first calculate the cumulative distribution function of 0 through 12. Okay, so that would be Binome CDF of n, which is 25 people, p, which is 0.42. And if I use 12, it's going to add the probabilities from 0 all the way up to 12. But I actually don't want some of those, right? So if I think about the ones that I want to get rid of, if I want 5 through 12, I'd have to get rid of the probabilities from 0 to 4, which if I find this probability from 0 to 12 and subtract the probability from 0 to 4, that's going to leave me 5 through 12. So that's exactly what I'm going to do. I'm going to subtract off another Binome CDF, n stays the same, p stays the same, but now I want to get rid of 0 through 4, so I'm going to tell the calculator 4. I want to make sure that I don't subtract off the 5 because I actually want to include the 5. Remember, it said inclusively. So if we want to include the 5, we only want to get rid of 0 through 4 in this case. Okay, let me go ahead and calculate that, and this will conclude the notes for today, excuse me. Okay, so Binome CDF of 25.42, 12, and then I'm going to subtract off a Binome CDF of 25.42, 4, and paste. Okay, so the calculator is going to subtract those two probabilities, and my answer is 0.7865 if I round that to 4 decimal places. Okay, guys, those calculator functions can shorten the time spent on those binomial situations quite dramatically. Remember, we have 2 different types. Binome PDF, that's for when you have exactly one x value, or a Binome CDF, and that's when we start at 0 and we go up to a particular number. But of course, you can use complement rule if you want to start at a number and go up. And if you want in between two numbers, remember you can subtract two CDF functions. All right, this concludes the lesson for today.